I want to take some time on this tutorial to go back to the basics with ladder logic and kind of give an idea what ladder logic really is. I want to talk about our inputs and outputs that we have shown here, how they work, how they go into the real world, what data files are, and how they enter into the equation as far as getting our information from the real world into the PLC and back into the real world again. Okay, let's stop for a second and maybe step a little bit back outside the PLC and talk about what's really happening and what you're doing. What we have here is we have a standard motor control circuit. You have a three-phase motor right here, and you actually have your control circuit over here on this side. Now you have your start push button, you have a stop push button, and then you have a typical relay with a seal-in contactor where when that relay pulls in, it actually seals around this momentary start push button. So that's our standard motor start-stop circuit that we have for a PLC. So what's the difference between the PLC and the regular hardwired option? Well, with hardwired, you saw we take our push buttons directly to a relay, and it acts directly upon that relay. With the PLC, we've had our start button, and it actually comes into an input card. It's wired directly into cards that interface directly to the processor through a rack or some other means. So both our start and stop push buttons from our other example, our previous example, both come in to an input card, and then they can be used and processed, and we'll see that later when we get into the PLC program. They can be manipulated inside the PLC program. Likewise, on the other side, we have our outputs, our PLC outputs, which is a different type of card that interfaces directly to our relay, motor contactor M1. You see it has a surge suppression device around it to protect the PLC output. Also a fuse, it protects the output. But generally the main thing you have here is you have this output directly from the PLC that goes to a relay coil to be able to operate some kind of real world device. So what this now gives us is this gives us a situation where we have our hardwired circuit above here, and we have our PLC ladder logic representation of that circuit. Now, this start contact, you see the difference, they're slightly different in the way that they are shown here, but this start contact correlates to the location that this push button comes into the PLC, and the stop contact also correlates to the position where this stop push button is wired into the PLC. And also, you know, with the output, the coils look pretty similar actually, but the coil then correlates to an output that's going to drive this relay now from the PLC. Now we have what's called internal contacts. This internal contact right here is actually not something that's coming in directly from the real world. It is actually something that's operating off of this coil inside the PLC and is being used inside the program. We can get into that, and I'll show you that a little bit more later. When we get into the program, I think it'll be easier to understand. Now, actually, I don't like to do this. This is not where we like to stop. We actually like to take this relay coil, take a contact that would come back from that relay coil, and then enter that into our PLC program. And therefore, we actually have a real-world understanding when we seal our circuit in. If this relay were to drop out for any reason in the field, then it would also drop our seal in the program. Even though our PLC program is operating and driving relays and working with equipment in the field, such as a standard circuit would that you might normally deal with. You have to remember that it is a program and it has certain ways of operating, and it's a very different program. So if you're used to a standard program, it's going to be different, and if you're used to just working with relays, it's going to be a little different for you too. What you need to understand first and foremost about a PLC program is it does not just operate from the top and go to the bottom and stop. That would not work well at all. I mean, it would scan through one time and then you would have no further operations. So what a PLC program does is it cycles through repetitively through the same program, and therefore constantly is updating and constantly trying to maintain the status of the different devices that it needs to control, and constantly monitoring the status of the devices that it needs to monitor. So what we have in a typical program scan, and not all of them are the same, and this is just an example. We might have a housekeeping section where the program does some communications updates or takes care of overhead in the processor. Then we have a situation where it would update the data table inputs. It would take those inputs that we saw from our previous drawing where they come in from the field, and it would actually plop that information into the processor so that it has that information available for it. Then it goes through a scan of the logic. It works, and there's different ways that different processors will work on the logic. Most will scan from left to right, and when you get into a branch situation like this, obviously there's some slightly different methods there too. I'm not going to go into that, but the main thing to realize is that then it looks through your logic. It starts at the top, goes down to the bottom, and works through your logic. Then finally, when it's done working on the logic, it updates the data table outputs, and then it goes back again to the beginning and starts the whole process over again. This is called PLC program scan, and a PLC program will scan repetitively as it's running and constantly updates its outputs, constantly checks its inputs, and that's the important thing to remember about programming in a PLC. PLC program scans are very quick. You will see them on the order of milliseconds and microseconds. So we're looking at information that's being processed very quickly, and obviously has to be able to monitor relays and to be able to monitor encoders and other fast-acting devices out in the field.